Hello everybody, hello my non-existent viewers. Well, good day to you, and it's time to solve some LeetCode problems. But wait a second. Okay, where is it? So, we already developed a tradition, to start with the problems that we solved on the previous day. So yesterday we solved this problem, and we solved it in the most stupid manner, but still we solved it, so I didn't beat myself too much because of the stupidity of this solution. But later that day I invented a much better approach. So let me comment everything out. I didn't yet see any solutions, so this one is again done by me, and it's a lot better than the previous one. Here is the previous one. We used array, we sorted this array, and then we reversed it, so it was awful because it's very bad in terms of big O, such a things. And even yesterday I said that problems like this one are usually solved by recursion, and ideally, we have this method increasing BST, and we should call it again and again and again to achieve the desired result. It was very hard for me to do this in just one method, and I'll explain why. First of all, well, let's start from the beginning. What is the problem here? We have all these nodes of the tree. Well, what is a node? Here is a class for it. Node, it has value like 5, 3, 2, 1, and it has like two branches, left node and right node. So for 5, for this node we have left node 3, left node 6, and each of these nodes also have value and two nodes left and right. Well, of course they may not have any nodes, like this 9th node doesn't have left or right, but we can postulate that every node at least has a value. So if we want to collect all the nodes and place them in that order, we definitely going to need, well, the node itself, So if we start at 5, or if we are here at 9, still we want to have a node. It's not that fast today. Not sure why. Let me close a few things. Yesterday it worked better. Let me just close something. So what is a node? Yes, it's an object of a 3-node class. It's very slow. So when we start our program, we start with this node 5, and from this node we want to create a new one that we are going to use in our tree. So we create a new node and we use value from this node in our new node, this one. And we do not have any left or right branches yet. It's just a node itself with a value. Now, of course, it's not that hard to add a right branch, to this node. We just have to check if our original node has a right node. So let's check. It's impossibly slow. Or something happened with my computer. I mean, every day it's a new bad thing. And now my computer is slowly dying. I don't know why. I hope I will find a job before it dies completely. So, we have a root. And we have our node. And for our new node, we are going to add a right node from our original node. So for this node 5, our new node, we add this right node 6. And it shouldn't be like this. Because here we just, took this node, but we always want to create a new one. It's a Vladimir. Hello? It's too slow today. Nothing is working. So we want to have a next node. And in the next node we are going to call again this method. Again and again and again. And at the very least, it's too slow. At the very least we are going to return the node itself, the newly created node, something like this. So for every node, we take the node itself and we take the right branch and we continue until we reach the end. So if we run this problem, we're already going to have like 5, 6, 8 and 9. I guess we'll see about that. Yeah, exactly. 5, 6, 8 and 9. Why do we have nulls here? Well, because we do not have any left branches. Well, we have it here, but we do not check for it yet. We only check for the right branch. Now, let's check for the left one. And here, I always had a problem previously. If we have a left branch, a left node, let's call it the previous node. Again, we want to call the same method for this root left. So at the very least, we will return the node itself. But also, how do we connect this previous node with our main node? We have 5, 6, 7 and what? 5, 6, 8, 9. How do we connect it to our 4 or 3 or 2 or 1? Well, our previous node oh no, it's too slow, it's almost impossible. How can Chrome work so slowly? It's impossible, but it happens. So our original node, not original, like our node 5 newly created, we use it as the right node of our previous node, and that's how it works. And of course I thought that this must be an end. Let's run it. Wait a second. Oh, of course we do not have to return a node itself. We have to return previous node. Or if it doesn't exist, then we want to return the node itself because it exists for sure. Let's run it like this. Yeah, video often stuck because it's very slow. I can't do anything. I don't know, nothing works. My computer is about to break. Let's see. And there are drops today. It's even worse. A very bad connection we have today. And yesterday there were no drops at all. I don't know, what can we do? Probably nothing at this point. Okay. So yeah, that's what I wanted to show you. We have this first node, and then immediately we have node number 5. So we do not have this 2, 3, 4. And why is that? Because when we create this previous node, we run increasing BST again and again and again. And in the end, when there is no more root left, what do we have in our previous node? We have this node, and to the right we have this, and to the right we have this, and to the right we have this, and that's it. But then we take this first node and we replace all these 2, 3, and 4 here. With our node number 5. This is a problem, and I didn't know how to solve it. Then I, have this idea, what if we use a while loop here? While previous node, right so this way, when we end at this last node, we go back to the right, and for this rightmost node we connect it to the node number 5. It's very hard to explain, but let's see what will happen now. Okay, now we have nodes starting from 5 to the last one, to the 9th, and even node number 4. But where are 1, 2, and 3? Well, of course we do not show them because we return previous node, and we change the previous node from being this leftmost to being node number 4, doing this while loop. And that's why I invented this new variable, let's call it last node among previous, and we're gonna run this while loop not for our previous node but for this new variable. Like this, and we're gonna connect it to node number 5, but we're gonna return still our leftmost node, and now it's going to work. Yes, it's all green now. So we achieved the same result by calling this method again and again and again, instead of using some arrays. And I invented this solution yesterday and was happy with it, but later I started thinking what happens here really. I think we run this while loop every time we call for this increasing BST, and when we have root left we do this while loop every time. That's my theory. I'm not sure, and we definitely do not want to do that, and it wasn't easy to find a solution for this, but my best idea is to do a while loop only if we do not have left nodes anymore. So this is our final node to the left. Only then we are going to run our while loop. Let's see. Oh no, wait. If not. Yes. And let's submit it. And it's probably going to work. Yes. And of course I want to look for a better solution here, and I want to solve some more problems, but for some reason my computer is too slow. It's too slow even to stream Google Chrome. How can it be possible even? Let me check. No, I have enough free space. I do not know why. Yesterday it worked. Well, I guess that's it for now, because I need to fix it. Maybe it's just too hot. Maybe I'll see you later today. But I need to investigate this problem. So bye.